Okay, guys, so today we're going to be looking at complex numbers. Let's do this real quick because I have to go eat and I'm really hungry, so whatever. So the complex numbers. Let's first start off by writing a complex number. What is a complex number? So what is, right? What is a complex number? Basically, it's any number that's not real, so to speak. So we can just do the following, for example. Excuse me, my actual definition is wrong, but yeah, I'm just trying to do this as quick as possible. But basically, imagine we have x plus 2i, no, sorry, plus x squared plus 2 is equal to 0. And we want to solve for x. So let's solve for x. This is going to be basically the square root of a minus a negative number. And this will turn out to be like an imaginary number, so to speak, because we have no square root for 2. So this will turn out to be 2i and minus 2i, right? That's our complex number, basically. Now that we have that, right, it's important to understand the following. A complex number can be denoted with this character, which is a zit or sed, however you want to pronounce it, is equal to a plus bi. Now, this, you don't have to understand it yet. I'm just explaining the introduction so you guys can understand it later. But this is basically just a real part, and this is basically the imaginary part. Whatever we have with I is going to be imaginary. That's why we have an I for imaginary or complex. So now that we have that, what comes next, right? Let me just connect my neck real quick. Let's say we have 3 plus 2i. Let's say this is set. This a bit because it's taking a bunch of space, right? If this is the case, then it means that this is our real part, real, and this is going to be our imaginary part. The cool thing about this thing is it's basically just like our x and y, so to speak. So you can see this as x, and you can see this as y in our graph. So that means we're going to have 3 units to the right. Let's say this is 3 units. So we go 3 units to the right. Oops, that looks absolutely horrendous. Oh, excuse me. Whatever, you get the idea. And we got 2 units to the top. So that means we go 2 units to the top. Right? So our point is going to lie somewhere around there. That's basically what you want to understand first. The concept of how this works. Now, you have to remember this formula right here. It's important. Now, we continue on. We have to now understand what the complex conjugate is. Now, let me just delete all of this. I was just taking some notes earlier, so that's why I was like, But let's say the complex conjugate is denoted by taking whatever, right? Sit is equal to that. So this is our complex conjugate. This is how you denote it, like in mathematical terms. And what this means is basically just taking our imaginary part and just making it negative or changing the sign of it, multiplying by -1, basically. So let's take a look at that. So it's basically going to be a minus bi, right? That's pretty much how it works. A minus bi, and that's it. So it's not that like difficult to understand. Now, another example would be, I don't know, 3 plus 2i, right? The complex conjugate would be 3 minus 2i, right? It's 2i. Now, sometimes when we want to solve something, we sometimes get the following structure. 3 plus 2i, right? Sometimes we get this. How do we solve this most of the time? This is basically just 1 over z, or z, sorry. So this is going to be equal to basically the conjugate on top and then multiplying our normal one times the conjugate of itself. So it will be looking something like this. 3 minus 2i. The conjugate in this case, the normal one is 3 plus 2i. He is over here. And the complex of that will be 3 minus 2i, right? So we're going to have 3 minus 2i, and 3 plus 2i, and then 3 minus 2i, right? If we just continue doing this, this is just a difference of squares, so it's going to be 9 plus minus 4i squared, right? Now, here comes another rule. I know it's a bunch of stuff we have to cover, but it's really easy, I promise. Sometimes we're going to have the value I squared. Whenever we have I squared, this is going to be equal to minus 1. Just remember that. It's as simple as that. So that means if we have I to the fourth, that means we have minus 1 times minus 1, so to speak. And that's going to be basically 1. I think. Yeah, actually, it's going to be 1. Why? Because we can just separate this. Hold on, I'll show you. We can separate it like so. I squared times I squared. It's going to be basically just minus 1 times minus 1. And that's going to be 1, basically. If we have I cubed, for example, what happens then? We're going to have I squared times I, which is going to be basically minus 1 times I. So we're going to get minus I. So that's basically how you work with squares in with i's, so to speak. Now, let's continue now, and let's try to do some exercises real quick. These are really easy. This is a good introduction to what we're doing right now. So let's go ahead and start that. Let's do the first one, which is going to be denoted as square root of 3 plus I cubed. And they're asking us to calculate the real and imaginary parts of the following expression. So let's just write that real quick. That's a quick instruction here, so we don't forget what to do. Calculate the RE and IM parts. Oops, no, parts of the following. So now we can simply take this and we can simply take our formula here. So we can take A squared. Actually, I don't like these colors. I know I'm really special like that, but you know, A cubed plus 3A cubed, squared B plus 3AB squared plus B cubed. This is basically going to be it's going to be square root of 3, 3, square 3A, and then B is going to be I, so I plus 3, I squared, yeah, then I cubed. So we continue, calculate this. Basically, this is going to be, is it going to be like that? Yeah. This is basically going to be 3 times square root of 3. Keep it that way. And this is going to be 3 square root of 3 as well. Well, hold on, that's going to be 9 actually. So it'll be 3 times 3 here, and then I, 3 square root of 3, and then I squared plus I, oops, it's just a cube. So this, we continue on calculating, and we have a 9e plus 3, and we already said that I squared is going to be basically minus 1, as we already said it here, right, over here, right? That means we're going to have times minus 1, So this is going to just turn everything into minus. And then we have here I cubed, which is going to be basically minus I. Why? Because we remember, I squared times I is going to be basically I cubed, right? But this is equal to, essentially, minus 1 times I. So it's going to be minus I, right? So we continue on. Oops. 3 square root of 3 plus 8I minus, oops, 3. So at the end of the day, we only have 8I. And that's a result. Simple. Now let's continue with the second one. Right? Let's continue with the second one here. The second one is one of the few cases where it's kind of confusing. But I already taught you how to like actually do this. You know? So it's not that difficult. You just have to find the conjugate and stuff. So yeah. Let's do that. So we start off by doing essentially this. And then we multiply, we get the conjugate on top, normal on the bottom, times conjugate on bottom. That means we're going to have 3 minus 2i, no, sorry, plus 2i, because remember, set is 3 minus 2i, then set conjugate is going to be 3 plus 2i. So we're going to have that. And now what I'm simply going to do is make this a bit bigger. So, yeah. 3 minus 2i, and 3 plus 2i, right? This is basically what we just did earlier over here, right? At the end of the day, it doesn't really matter, but yeah. So we continue on, 3 plus 2i, and then here we're going to have 9 plus minus 4i squared, right? This will change into 3 plus 2i. 9 plus 4. Why? Because of the I squared. 3 plus 2i is going to be equal to 13. So at the end of the day, this is basically that. This is our result. Right? We can continue on. Let's do another one. Into here, maybe 3. Now, within the complex numbers, sometimes you're going to get this type of exercises. 1 minus 2 times I squared. And then that. The little marks here, the little marks that we have here, these two, they denote basically the scalar, the magnitude of our thing. So it's magnitude. And if you know physics, you know how to do this. It's really simple. We have done physics. It's really quite simple. So we're gonna first off just focus on the part in the inside or magnitude signs. So we can just work around with that. So it's gonna be basically square of the first one, so 1 plus double of the first one times the second one, so it's going to be minus 2 times I, then square of the second one, so it's going to be 2i squared, I think. Yeah. We continue on calculating. At the end of the day, we're going to have 1 minus 2 times I minus 2. At the end of the day, we're going to have minus 1 minus 2 times I. So now we're going to do the magnitude or whatever. And that's quite simply just done like it's following. Just take this squared plus, let me take the second value without the I. Remember that. We don't include the I in this case. So we're going to have 1 plus 4 times 2, which in the end is going to be 1 plus 8. So that's going to be 9, 3. There you go. That's your result. Now let's do the last exercise here. Right? Oh man, this is tiring. Okay, 1 plus 2i, and then the complex conjugate of that, minus 1 plus 2i. Now, how you find that is quite simple. We know that 1 plus 2i is our tzit. So tzit of that is going to be 1 minus 2i. So now we're going to replace here 1 minus 2i minus 1 plus 2i. We're going to do the negative sign now. Minus 1 minus 2i. And this is simply going to be minus 4i. So yeah, guys, this is pretty much the introduction to our complex numbers. It's really not that difficult to understand. And yeah, thanks for watching.